About 7 or 8 years ago, I was involved in a large research consortium that was trying to develop a better prosthetic hand. And they realized that prosthetic hands needed tactile sensing, and we realized that there were no tactile sensors that were really suitable. So SynTouch's mission really is to provide machine touch. That is, both the sensors and the ways to use that information to make intelligent decisions about the world, about objects in it, and how to handle them.
My name is Vikram Pandit, and I'm an undergraduate student at USC. I'm a congenital unilateral amputee, which is a fancy way of saying I was born with one hand.
The way Vikram uses his hand is just a wonderful justification of the whole biomimetic design strategy, because he used it in ways we never dreamed of.
When I got here, I did a series of experiments about how the biotech could benefit a prosthetic user. The most useful thing that we could do right now was something called contact detection in the biotachs. When the two biotachs on opposing fingers make a certain amount of pressure on any object, the hand would just stop. The first time I had used it, we had ordered sushi, so we had little Chinese, foldable, pliant boxes, and I kind of just picked it up and started using it. Our electrical engineer came back into the room. He was like, "Oh, Vic, did you even know that you're already using the hand?" And I was like, "Oh, it works."
I think the biggest hurdle was finding a way to combine the mechanical properties of fingertips with the sensing.
That involves everybody sitting around and saying, okay, what do we want this product to do? What are the constraints? What things do we want to make better? There's always challenges, so you have to come up with innovative ways to solve those challenges. And SOLIDWORKS allows me to do that.
We've started using 3D drawing packages, I think, the day after they were invented. We gradually found that SOLIDWORKS was a good mix of the tools that we needed and interfaces with other packages, such as computer-aided machining, which is something that we use regularly.
We can use a method called DMLS, direct metal laser sintering, to make this part in strong materials such as titanium or stainless steel. Most, if not all, of the machine shops and prototyping shops accept SOLIDWORKS files. In fact, they prefer SOLIDWORKS files. So SOLIDWORKS works for everything, basically. Now, at present, we use a flexible circuit for our printed circuit board, which is then injected with epoxy. The electronics are buried inside the epoxy, so they're not accessible. So if something goes wrong with the biotach, you don't have any way of troubleshooting it. So for our next iteration of biotach, we decided that we wanted to have something that could be made modular, so everything is independent from each other. The blue lines here represent the traces for the 2D printed circuit, and then we project them onto the 3D surface. So all of these will become electrically conductive traces. They're about the size of a human hair. There's not very many software programs that could do it, other than SOLIDWORKS.
I wouldn't truly consider it a hand until you don't ever have to think about it. It actually simulates a real reflex of the human body. We're getting there. It's going to happen soon.
I think people are starting to realize that this really was an important sense and that it was largely missing. It's easy to stop at a level of, well, here's a solution, here's an article we published in a journal. Sooner or later, if it's actually going to do good for a real patient, someone has to take the idea and the technology and make it a product that's available commercially. And in the case of SynTouch, that's what we decided we had to do ourselves.